All right. Hello, everyone. Oh, wait. The mic. We're not going to worry with the mic. Yeah, thank you for coming. My name is Robert. So I'm with Oasis, as introduced. I'm a BD specialist. So my main goal with Oasis is to grow our ecosystem. Onboard more developers, educate developers, basically make people more aware not only of Oasis but also what TE and AI can do when put together. So that's kind of what I'm talking about here today. The name of the talk is TEExAI, Trust But Verify, and you'll see in a moment why that is the case. So without further ado, let's get into it. So first, what do we mean by AI? I think most of you probably have some idea of what AI means at this point. ChatGPT is pretty ubiquitous, so we could say typically we mean large language models. And particularly we mean chatbots, most of the time. Yeah.
Can I shout blasphemy?
Yeah, well, there's always exceptions, right? That's why I put typically. It's not, yes. So LLMs are a subset of AI, but I'm going to focus in just on those for most of this talk. So normally we think of ChatGPT, we think of Claude. We also might think of image and video generation. So all of this would be considered generative AI. So something like Midjourney. And so there's, of course, a lot more that you can do with AI. There can be all sorts of productivity tools. There can be self-driving cars. There can be image recognition, everything. But we're going to focus down mainly on LLMs just for this talk. So next, the question would be, okay, well, what is the TE? And I would say most of you probably don't necessarily know what that is, or if you do, you maybe have some vague idea of what it is. So the short version is that it's an acronym, and it stands for Trusted Execution Environment. Okay, but what does that mean? Well, it's complicated. The really complicated explanation would be by pulling up this 118-page PDF online, Intel SGX Explained, which goes into all the intricacies of how trusted hardware works and attestations and all of this stuff. And I don't claim to fully understand it or be able to explain it to you in 15 minutes, but the link is down there if you're curious. We could simplify a bit and say, well, it's some sort of computing environment where we have a non-secure world where we have apps that we don't necessarily trust with our data. And then we have a secure world where we have these trusted apps running with some protected hardware resources. And basically, that's the gist of a trusted execution environment. We're taking some hardware, some chip, some CPU or GPU, and we can trust the data running in it. And if we really want to simplify this explanation, because that's still too confusing, we could just say that it's a black box for computation, and that gives us privacy. We take some data, we stick it in the black box, it does something to it, it gives us an output. And this will either be a CPU for normal computation or a GPU if you're doing something like AI, where we need to use GPUs because of how compute intensive it is. And one little extra bit of detail is, I might have mentioned this word earlier, it implements an attestation mechanism. And all you really need to know is that this gives us verifiability. This is a crypto audience, and I think the big takeaway here is that anything involving crypto, blockchains, we care about verifiability. With Ethereum, yes, it's transparent. That's good in certain instances. What we really want to know is that the code that we upload and that we try to interact with is actually the code that it says it is, right? That's the key aspect of blockchains that we care about, verifiability. So what if we combine the two? We take TEs, we take blockchains, we put it together. Well, Oasis has kind of already built this. You can have a secure enclave, take some encrypted data, take some smart contract code, stick it all together, and you can get some encrypted results. You could have functions, you could have arbitrary logic. And when it's in an EVM, this is what we built. We call it Oasis Sapphire. This is a product that we've developed. It is the first and only confidential EVM blockchain that's in production. It's live on mainnet today. And basically, in a very brief way, the way it works is you have a network of nodes that run Intel SGX. And as a result, all your transactions, all your call data, and all your smart contract data can be completely encrypted by default. But the real kicker is it can be selectively unencrypted. So you don't necessarily have to have everything completely hidden. If you want to reveal certain information based on some condition, you could do that. Yes, please.
I'm just confused by this. I thought about this a little bit. Like, how do I know? You tell me you're running some software inside of some hardware chip.
Yes.
In your server farm.
Yes.
How do I know?
So that is essentially where attestation comes into play. So the way, kind of the brief overview of what Intel SGX and other designs, the way they work, is that you have this hardware, there's a piece of hardware that basically the architecture is constructed in such a way that it can prove to you that whatever code you're running inside of it is the actual code that you've provided it.
I've given it the code.
So you give it a piece of code, you say run this code, and it'll give you not only the output, but it'll give you a proof that it ran that output. It's not quite the same as something like zero knowledge proofs. That's more like almost a mathematical cryptographic guarantee. This is cryptography, but it's more of a hardware level. It's similar but different. But yeah, like I said, it's really, really complicated. So I can't pretend to be able to explain it all here.
Is that what the SVM means? On the previous slide. EVM.
EVM? Yeah, EVM.
What is EVM?
Ethereum virtual machine. So when we say EVM, we just mean any blockchain that is similar to Ethereum that uses the same kind of architecture. So that might be Base or Arbitrum or Avalanche. They're all EVM-based blockchains. All right. So Oasis Sapphire, like I said, it's a confidential EVM. What can we do with it? Why is this interesting? The kind of low-hanging fruit would be we take DeFi, which we already have on Ethereum. We add confidentiality. So you could have private swaps, for example. Or if you want to get a little more fancy, what if you have lending and borrowing where the liquidation threshold for a given loan, a given debt, that is actually kept hidden. Right now, if you're, let's say, using Aave on Ethereum, and let's say you're a whale, we would like to imagine that we're whales, but maybe most of us aren't. You might have a very large position that can actually get hunted. Like there are people that can actually manipulate the price of an asset to try to liquidate you and get your money. And this might be difficult to do, but it's at least possible. But if you hide your liquidation thresholds, this is no longer possible. In terms of DAOs and voting, this is more low-hanging fruit. You could basically have a private DAO vote, and maybe you want to reveal the results of the vote after it's completed, just like in a normal election, right? We don't want everything that we vote for to be kept public because maybe there's some way that people can kind of coerce you or otherwise bribe you. I think private voting is something that we intuitively understand in a democracy is important. So this is something we actually built in-house. We call it Block Vote. You can access it today just at this link, vote.oasis.io. And it has a lot of features I can't get into, but yeah, basically you can have, let's say, only holders of a specific NFT or a specific ERC20 token are allowed to vote based on a certain weighting. So it has all these kind of customizability, but lets you do private votes. The next one is gaming. This is maybe less popular, but I think still interesting. So if you're an on-chain game, then right now, if you're on Ethereum, you really can't have anything hidden. You can't have a riddle or a puzzle or any secret that would make a game engaging. On Oasis Sapphire, you can just do this natively quite easily. All right, so this is all cool, but this talks about AI. So what's going on with AI? Can we do this on-chain? What's going on? Well, LLMs, I know not all AI is LLMs, but LLMs are AI. They typically require GPUs for training and inference. So blockchains don't really use GPUs. They're running in the CPU. The outputs are non-deterministic, meaning that if you give an input, it's not necessarily going to give you the same output every time. That doesn't really work for the way blockchains replicate computation. And they're also very compute intensive, which is also difficult because blockchains tend to not scale great. And also blockchains can't access the web without using some sort of trusted oracle to relay that information. And so you would have an AI that doesn't have access to the web either. So kind of a lot of issues actually running AI on chain. So then your next suggestion might be, well, what about off-chain? I know this is a crypto audience, but let's entertain the idea for a moment. So we could maybe use a centralized cloud provider. They offer the use of trusted execution environments. You can use Google Cloud or you could use Microsoft Azure. And this sort of would work, but then the question is, can we trust them, right? And so if the answer is no, then we can't do that. If the answer is yes, we can trust them, then why use blockchains at all? So we need to find a better solution. And this really all stems back to why do we care about verifiability, right? This is what blockchains are based on. How do I know that I'm using some large language model? How do I know I'm receiving outputs from the model I actually paid for? How do I know my data is being handled appropriately, that it's not being monetized or trained on without my permission? And how do I ensure liveness? ChatGPT, for example, very robust service, very popular, but it's a paid service, but it has had outages before. Only for a few hours, not the end of the world, but maybe you have a business that you're relying on that perfect liveness, right? Maybe it is very important to you. How do we ensure all of these things? It's an interesting question. So for the first question, am I getting what I paid for? So here I just have a very simple chart. I just pulled this from API data. You can basically pay. This is on the y-axis here. We have dollars per million tokens, which is just some amount of output, the cost per output. You could think of it as. OpenAI 01 is basically their most sophisticated model out right now. It has like PhD level mathematician reasoning, and it's very sophisticated. Also very expensive. Something like Microsoft 5.4, which was also recently released, much more compact, much more streamlined. Still pretty good, but obviously much cheaper. Now, it doesn't cost zero. Let me zoom in. You can see that this goes off the chart. But this only costs like 14 cents, and this is $60, which is a 400x difference. So if I'm paying for the left, I want to be getting the left. I don't want to be getting the right. How do I know that's going to be the case, right? You just have to trust these companies right now. So is there some better solution here? And of course, I'm here because, yes, there is a better solution. What we can do, and there's some coloring here, but I don't know if you'll be able to see it that well, but we have that we can combine the off-chain computation running in a trusted execution environment with remote attestations posted publicly on-chain. There's a lot of words, but we can break this down and link things together. So we want our applications to be scalable, right? Blockchains can scale somewhat, but we already figured out that for AI, it's not really going to work. So if we want to scale AI, we got to do it off-chain. But we want our AI to have confidentiality features, which means it needs to run in a trusted execution environment. We also need it to be verifiable. Otherwise, we're giving up on all of the ethos of what crypto is about. That's where the remote attestation comes into play. And so we got into ROFL. And now this is an acronym. It's not the acronym you're thinking, but this is one of our latest products that we're building. There are not many others like it, but I would say this is kind of where most projects in the TEE space are heading towards, is this combination of verifiable off-chain compute and combining it with blockchains. So what is ROFL? Well, it actually does stand for something different. So it's runtime off-chain logic. And essentially, a brief overview of how it works is that developers can create these policies. It anchors these policies on-chain. And then node operators can run specific binaries, meaning they can take a piece of code that you give them, and they can attest that, yes, I am running the code that you gave me, and you can essentially trust them as an oracle. And you're not trusting them in the sense that, like, I'm just trusting you to do the right thing. You can trust them in the sense that they are a centralized provider posting data to a blockchain, but you can actually prove that what they're posting is what it should be because it has that attestation process. And the last bit, which really makes it interesting, is that this does not just run for the CPU, which would be Intel TDX. It actually can do LLM inference and training as well, which would run on the GPU. And the main reason that this is possible is because NVIDIA specifically saw the value of TEEs, and so they built the H100 to natively support a trusted execution environment in the chip itself. Like I said, this is a hardware-based system, so it has to be built into the chip based on the manufacturer. And so they saw the value of this, not necessarily for crypto, but just in general. They saw the value of private AI-based systems, and so they added this feature. So this is just another diagram explaining ROFL. I'm not going to explain all of this, but basically, if you run an app inside of ROFL, you're able to interface with on-chain logic. You're able to do things also off-chain, like getting queries, APIs, acting as a price feed. Maybe it's a bridge between two blockchains. All the stuff that you can't do on-chain. The idea is to do it off-chain in the most in a robust way possible to make it verifiable. That's the whole goal. Okay, well, if we could do all this off-chain and make it pretty verifiable, then what about Sapphire? Didn't we just say that that was super important? Well, some things you're going to still want to have on-chain, right? You're going to want automated payments that are trustless. You want users to be able to control their own funds. Execution logic still needs to be handled on-chain when you need like persistence. So if you spin up this raffle application, it might only be available for some time. It's essentially you're using the cloud more or less. But a blockchain, the whole appeal is that it's there forever, right? So there's parts of the blockchain that we still definitely need. We're not getting rid of it completely. And ideally, what this means is we want some decentralized rails to build our applications on. And then any parts that need that greater flexibility, we can move that off-chain as we see fit. So it's going to be a combination of both. And the reason that you would want to use Sapphire specifically is, instead of just any other blockchain, is you're getting that end-to-end encryption. So you have the off-chain TEs, the confidential smart contracts, and you're combining the two. You could use Raffle with, let's say, Ethereum, where it's transparent, but then if you need some private data or something and you post that on chain, you're going to run into issues there potentially. So ideally, you just have the full stack end-to-end encrypted. I think that makes the most sense for a lot of use cases. So let's get into those use cases. This might be a little controversial, or maybe it's going to be seem a little pointless, but I think it's the easiest concept to wrap our head around right now based on what's currently happening, trends in crypto. So let's talk about AI agents. Everyone loves AI agents, right? So they imagine an autonomous AI agent. You're running it off-chain as this Raffle application, and you give it access to some on-chain wallet, some Ethereum wallet maybe. Well, the question is, who controls the private keys? Because you have to store the private key somewhere. If you store it in the Raffle application, well, that application doesn't have guaranteed liveness. The whole point is that it's off-chain, so those keys might disappear. So we can't store it in the application. We can't store it on Ethereum because Ethereum is transparent. So we're still kind of in this conundrum of we need to store our private keys somewhere in order to actually control the funds. And so this is where Sapphire actually comes into play, I think, the most, is key management. And we are actually building key management as a service, which I don't know the timeline on that particularly, but that's something we're working towards to make it as easy as possible. Basically, you could have the ability for some agent or even a user to give permission for their private keys on any number of blockchains. And since Oasis Sapphire is private, you can actually put a private key inside a private smart contract and everything is kosher and it works out. Another question is, well, what if the node operator shuts down, right? Well, then, like if your Raffle app, it has one node operator, let's say, it's not a blockchain. It's just, you just say, hey, this one node, I want you to run this piece of software. You might run into issues. So then in that case, you might want to have multiple instances and kind of spin it up and down as needed. That gets into the more nitty-gritty, I would say. Another interesting use case, this is actually sort of live, but there's some caveats, is this app called Simulacrum. And basically they're addressing wallet management. So right now, everyone probably realizes that using MetaMask and stuff long-term is not going to be how crypto works, hopefully. It's cumbersome. You got to write down your seed phrases. You got all these ledgers and buttons, and it doesn't make a lot of sense. It's not like the Web 2 experience. There's got to be a better way. So there's a lot of account abstraction solutions already being developed. Some of them might use Web 2 credentials, maybe like a social recovery type thing. You use your Google account to log into your crypto account. This is kind of in that vein. But we could go a step further. Basically, what if we use just social media posts as our crypto wallet? We never create a wallet in the first place. It's all done on the back end. It's all done using smart contracts. So here I have this picture. This has a little bit of information contained in it, but basically we have this automated Twitter bot. It's talking to Binance, or CZ of Binance specifically, and it's using this syntax here. It says #Simu, #tip, $500 at CZ. And I just have shrunk it here, and now we can see that another automated bot, Simulacrum, which is the app, basically does this all on chain. So what it's going to do is it's going to monitor on chain, monitor on Twitter in this case. It's going to look for this specific syntax. It's going to say, okay, this Twitter account is creating this command, and then it's going to create a smart contract wallet associated with that Twitter account, and then do some action. So here it tipped $500, and it sent the money. You have to have the money in the first place, of course. But yeah, that's basically what just happened, is you have an AI agent, it makes a post on social media, an executor, which right now we can call a trusted oracle. It creates an on-chain transaction, it posts the transaction hash back on-chain, and then the recipient can access their funds just by using another social media post down the line. So it's all done using social media, which is pretty cool. This was in CoinDesk. Some of you may have heard of AI XBT. It's basically just another one of these AI agents on Twitter that's very popular. Again, is the utility there yet? Maybe not, but I think this is just the most relevant in the short term. It used Simulacrum actually to launch a token. So you have something that is non-human automatically using another kind of LLM tool to interact on-chain and deploy a token. So basically, we're now getting these systems where the utility might not quite be there, but the autonomy is starting to get there. And they're kind of just doing their own things now. So this was, I consider this kind of a watershed moment, even if it might not seem that significant, just because of how strange it is. Like, it's weird. But there is room for improvement. So Simulacrum right now is not running as a raffle app, which is the whole thing I've been trying to impress upon you, is we need that verifiability. But it will in the near future. That is part of their plan, is to implement that. So you're trusting them for liveness right now, but the way it's been built doesn't control user funds, which is nice. So when it creates that Twitter wallet, essentially, just because it's creating the wallet for you, doesn't mean they can actually do anything with it unless you actually tweet. But yeah, this also means we can't verify if all these autonomous agents are actually autonomous, right? So we have two different ones right here, right? We have AI XBT, we have Simulacrum, we have Simi, we have all these agents, and how do we know it's actually an LLM doing this? How do we know it's not just some guy on his computer logging in and trying to send a post or something? Well, it's really hard to know right now. But the whole point is you run your off-chain applications in a way that it's verified, and then you know for sure that, yeah, this was automated. This was all done in this black box. So yeah, there is room for improvement. And then the final thing is when raffle, right? So we like to talk about, hyping things up and saying what we can do, but can we actually do it right now? Not quite. So we support Intel SGX, which lets you write applications in Rust. We're working on support for Intel TEEx, which will let you create containers and therefore kind of create apps that work with any programming language, which will make it a lot more robust. So that would be in terms of CPU usage. And then the final step is NVIDIA GPU support, which comes after that. And we've actually purchased an H100 to use for testing. And here we have our head of AI at Oasis, Marco, kind of memeing. But if you're a guy in your early 20s, buy an H100. Go into debt if you have to. This is kind of floating around Twitter the last week or so. So we got it. We got the H100 now. So we're working on that. So there's still steps to be made. But that's the biggest takeaway, is we want to have some things done off-chain. We can't have everything done on-chain. But if we're going to do it, it should be verifiable. It should be private, because everyone cares about privacy, hopefully. And yeah, it should be at least decentralized in part. So yes, please. Both. Well, that's the whole point, is our blockchain. So on a normal blockchain, you cannot be, right? So if you're using Ethereum or any other blockchain for the most part, they're built to be transparent. This is a separate blockchain. It's a layer 1 that we have built, and it basically lets you send private transactions. Right. Exactly. So you can choose what is transparent and what is private. You can write arbitrary functions, right? So if you create, for example, a private variable, it's actually private. Whereas on Ethereum, it's not really private, right? But you can create a function then that reveals that information under a certain set of conditions. So you can do both.
Then the question is,
why why do you want to be on layer one and have transparency? Why not just like the transparency part off chain? I mean,
The privacy part off chain. Well, yeah. So a lot of applications can do that. Some of it for some stuff, or maybe a lot of stuff, you can just offload the private part off chain. We kind of already have this in mind. I didn't talk about it here, but we have what we call the Oasis privacy layer, which is basically if you're on another blockchain, let's say you're on Ethereum or something, for the most part, you're okay with it being transparent. But every now and then, you want something to be private. Maybe you want a DAO vote to be, like I showed the block vote, right? I mentioned you want a private DAO vote. You don't want your whole DAO, your whole blockchain to be private, but just this one vote. What you can do is use block vote, which essentially is going to route your DAO on another chain through our chain, and then send the message back. So you're kind of like relaying messages. It's still technically on chain, but in basically what you're saying is, why can't you offload your work when you need to? And that's kind of what we had in mind. So it's just, I think the best way to answer it is just, it depends on the use case. Yes?
You mentioned private smart contract a number of times.
Yes.
What is that? Where does it run? Is it encrypted? How does it get unencrypted?
Yeah, so essentially our architecture, we have a layer one, and we actually allow for multiple rollups basically on our layer one, but the main rollup right now is Oasis Sapphire, which has the private smart contracts. So it's a network of nodes that they all have the same hardware or similar hardware, and it's called Intel SGX. There's other types of hardware you can use in principle, but that's what we use. And so by using that hardware and doing these proper attestation mechanisms and all these things very carefully, you can have it such that the person operating the node can't actually see the data that's inside of it. So you can actually verify that this is private not only to the third-party public, but actually to the people running the nodes themselves.
So is a private smart contract encrypted by me? The private key that's inside of that hardware?
Yeah. So actually, each smart contract itself has its own private key, and so that gives you a lot of flexibility. So the short answer is it depends how you want to build it. You can build whatever you want. If I want to build something that is just completely private end to end, nobody can see anything, then I could do that. And then when a user interacts, they just sign with their private key, and they just interact that way. Or I could have it where maybe some stuff is revealed, and maybe a user signs a transaction that does the revealing based on permissions. But you almost just think of it as, how does Web 2 work, right? Most of it is kind of private in a sense. It's not private to the, let's say we're talking about like a bank. I have money in a bank, Chase or JP Morgan, whatever, they could see the money, but nobody else can. Unless I wanted to take a screenshot and show it to other people, right? So it's kind of like that, where it depends how you want to build it, what level of privacy you get.
When you started off, you were talking about how you mentioned ZK proofs.
Yes.
It's similar but different.
Yes.
Hardware-based approach.
Yes.
So what's like pros and cons?
Yeah. So
why did you go down that path?
Excellent question. So I see them overall as complementary technologies. ZK proofs are, I guess, more robust in terms of knowing for sure that what you prove is actually true. But actually, that's not a good way of putting it. But I mean, it's true. I mean, it is true. But let me take a step back. So trusted execution environments, they're very complicated to work with in terms of building it in a way that doesn't leak information. There have been exploits in the past for TEEs, so that is the big caveat here. Currently, all the exploits have been patched for quite some time, so they seem pretty good. But you don't want to just rely on that. Ideally, you use TEEs and maybe some multi-party computation as like a second layer, and you create ways where even if there was an exploit to the hardware itself, it's not going to just reveal everything. It's not going to compromise your whole blockchain. That would be a disaster. So they are a little bit trickier to work with, but the benefit you get from that is the scalability. So the compute overhead of zero-knowledge proofs is very high. And so if you want to have these large blockchains running a lot of different transactions, doing swaps and all this stuff, we're almost there with ZK, but not quite. It's like most ZK protocol, all ZK protocols that want to do smart contracts, they're all on testnet still. They're still working towards deploying to mainnet, but it requires a lot of research. I think in the future, ideally, everything runs in ZK and we're all happy, but I don't see that being the case in the near term. And if we want to build things today that are useful, then you kind of need trust execution environments, at least in part.
Can I ask again? I was what's the main value proposition of doing AI on the blockchain?
Yeah. So the idea is, let me give you a simple example. So let's say I want to, run my business and use OpenAI for some aspect of, optimizing my workflow, or maybe I'm trying to create software that I'm going to monetize, right? And I want to use like the best model, or a really good model at least. But if I put this into OpenAI today, well, they're going to get all of my data. They're going to get all of my code, my whole thought process behind it, how my business is structured. They're going to have that data. They could not only train on that data, but then what happens down the line when they release a new model that was trained on that data, and someone prompt engineers a way to get that information back out. It basically, you run the risk of whatever data you're putting into these models can be leaked to the entire world down the line. So that's where I think privacy is important. And it might not just be for business, it might be for personal matters that have no clear monetary value, like maybe I'm using an AI therapist and I really don't want that to be shared with anybody else. Then you're going to want that to be kept verifiably private. So there might be a lot of reasons, but I hope that answers your question. Sorry, yeah, I'll go ahead first.
Okay, I have a question. So you mentioned the ability to do, for example, like training.
Yeah.
More complex AI things than just is that working currently within Oasis?
Training?
Yeah, the more complex things.
Gotcha. No. So right now the GPU support is not enabled. So if you want to, let's say, like run, so there's kind of like two steps in terms of doing verifiable AI. The shortcut is you have your application and then it pings an API, but that at least the application is running in a TEE where there's kind of a breaker, right? That's a shortcut. But ideally we don't want to just use a centralized API, right? If we really want to do things properly, we run the whole model inside of the TEE, but that does require GPU support. You can't run a model inside a TEE unless it's a really tiny model that just uses CPU for some reason. But most of the time, that's not going to be the case. So you need that GPU support, and we don't have that right now. That's something we're going to have this year.
Is there a timeline or a white paper for how that's going?
We're iterating quickly. I would say just keep an eye posted on our socials, basically. We don't have a specific white paper, though. But yeah, so TEEx support, which is the prerequisite for supporting GPUs, that we want to have on testnet by the end of the month, maybe. And then GPUs within the next few months after that, hopefully.
You already have an H100. You already have one of that video. Maybe.
You had a question next, right?
Yeah, so we're always good with this on the private side.
Right.
So the user can be able to analyze the data and interpret it. Are you going to be able to
like for DeFi, for example? Or, well, yeah, I mean,
it's better to think about it from a business perspective. Most people don't think about that.
Right.
So real business, balance sheet,
okay. Yeah, well, no, all that could be still revealed to you as the user. I mean, it would be private to everybody else, but you might have some business transaction that is posted on chain, for example, where you can see the transaction, your partner can see the transaction, but nobody else can. Or maybe it's you, your partner, and the U.S. government for regulatory reasons.
I get the theory. I'm just wondering, is it more difficult to figure out what's going on?
No, I don't think so. I think it's just how you build it. I mean, maybe technically it's like marginally more difficult, but it's just you just have to choose who can see what data. Oh no, I mean it's a common question, I would say, but I think it's pretty trivial to implement.
I was going to ask whether you think you could use blockchain to verify a federated AI model being whether the correct parameters and the correct distributions are being used during forward and backward paths, during inference and training, such that there can be more explainable AI.
Explainable in terms of like the inner workings of how they think. Are you saying in that sense, or I might not fully
know exactly what parameters and what the distribution is using at any given point of model.
That's a tough question. I mean,
where each of these like components within the model are distributed across many GPUs, across servers.
right. I mean, I don't think this provides an advantage in terms of probing more information. Like, you're not going to gain any new information based on what we already have, right? Right now, we just have these big server farms with clusters of GPUs, right?
Because for the most part, even when I do my AI models, I have no idea what's happening.
Yeah, I don't think it's going to help with that really. But I think it's more about proving kind of the key milestones, right? Like, are my weights what I think they are? Is my prompt what I think it is? Is my output based on those two things roughly what it should be?
Even being able to like prove that, that's very valuable.
Yeah, I mean that's about. Yeah, I mean if you're relying on on a centralized service where you have none of that information, then yeah, it's valuable. Like, I mean, I don't know if this actually did happen, but I've seen rumors that like people were like using ChatGPT, then one day it just got really bad all of a sudden, even though it was the same model. People were like, oh, they nerfed it or they changed the weights or something. Maybe that happened, but that shouldn't even be a question. It shouldn't be like, oh yeah, the thing you were using that was important for your business, yeah, it doesn't work now. Sorry. Like it should be verifiable at the very least, even if it isn't private. So I think it's still very important.
Any more questions? Or all right, let's have a round of applause for Robert.
Thank you.